As you remember, probably I think a chapter ago, we did a lot of working with quadratic expressions, with any equation that has squared in it. We found minimums, we found maximums. Today we're going to go back to solving quadratic equations, and we're going to go back to completing the square. As you remember, our first step when we're completing the square, our first step is always to move c to the other side by adding it or subtracting it on both sides. Now that we have it like this, in the past when we were using completing the square to rewrite formulas so that we could graph our parabolas, I would have told you to factor out 2. However, this time because we're solving the equation, we don't need to go to the step. I would have also told you to leave the 2 and not do anything with it. However, what we can do now though, because we're solving the equation, is to get rid of this 2 that's multiplying all of this whole thing here by dividing the entire both sides of the equation by 2. We then get x squared plus 10x equals 4. Our next step then is to divide b, or this number here, by 2 and square it. Then we add it to both sides. So 10 divided by 2 is 5, and 5 squared is 25. So what we then do is add 25 to both sides, and we get x squared plus 10x plus 25 is equal to 29. You'll now remember that because this is a perfect square, because 5 times 5 equals 25 and 5 plus 5 equals 10, we can rewrite this using whatever number we got when we divided b in half, and we just stick it inside here. So because this was positive 5, we do positive 5x plus 5 squared is equal to 29. So in the past, when we were completing the square in order to rewrite expressions, I would have told you to move the 29 back over here. But because now we're solving the equation, that's not what we do. It's actually just like yesterday's homework now. We can take the square root of both sides, and we get 29. Because 29 doesn't have a perfect square root, we just write plus or minus square root of 29, and we get x plus 5. Don't forget the plus or minus. It's super important that we have the 2 answers here. Okay, and then we can just use SADMAT properties to move the negative 5 over here, and we get x equals negative 5 plus or minus the square root of 29. You can write it like this, but don't forget that this is actually 2 answers. Negative 5 plus the square root of 29 and negative 5 minus the square root of 29. You could go ahead and do that with your calculator, but for the purposes of this homework, you can just leave it like this. And again, just to review what we did talk about last chapter, the minimum or maximum of a quadratic equation is always the parabola's vertex, which means the point which it either opens up or down. So in this particular parabola, this is a minimum, and in this parabola, it's a maximum. Really quickly, I do want to review rewriting parabolas in vertex form by completing the square, which is something that we did about a chapter ago. So I would go back and make sure you review your notes on that as well. But I'm going to kind of do a lightning speed review of it here. So the first thing we do, remember, is we set it to 0, and then we move c over to the right. Please remember that if we're rewriting it in vertex form, so the last example, we were solving the equation. In this example, we're finding the vertex form of the equation. So when we factor out 2, we do leave it, we do not divide both sides by 2. Now that we've factored out 2, and we are going to leave it here since we're not solving the equation, we're going to take this number, divide it in 2, then square it. And then we're going to add it, and we make sure to remember that because this number is being multiplied on the outside by 2, when we add it to the right side, the side that doesn't have the quadratic equation, we have to make sure we're also multiplying the addition by the same number. So because it's being multiplied by 2 here, I multiply it by 2 here as well. So now we can convert this, we can factor it so that it becomes a perfect square. 2 times 2 is 4, 2 plus 2 is 4. Now that I have this, if I'm finding the min or max and I'm rewriting it into vertex form and I'm not solving the equation, I just move the 10 back over, and I get 2, x plus 2 squared minus 10 equals 0. And we remember that if we're finding the vertex of a parabola, this is in vertex form now. The plus 2 means it's been moved left 2, and this minus 10 means it's moved down 10. So the vertex of this parabola is at the point negative 2, negative 10. Now we have to decide if it's a minimum or a maximum. Because this equation here has a positive leading coefficient, we know that it opens up like this, and therefore this value is a minimum. Okay, just for good measure, I'm going to do one last example of solving an equation using completing the square. So in this case, I'm solving, I'm not finding a min or a max. I see that C is already moved over to the right side, so I don't have to do anything with it. Then I look at B, I divide it in 2, and I square it. Then I add that number to both sides. So I'll get x squared plus 8x plus 16 is equal to 6 plus 16. Then I remember that this is a perfect square. Then I take the number that has been divided by 2, so 4. I see that it's positive, so I write plus 4. Then I fill that in and write it as a perfect square. Then using what we learned last lesson, I simply square root both sides, and I rewrite it as x plus 4 is equal to the positive or negative square root of 22. Then using SADMAP, I just move everything back over to the other side, and I get negative 4 plus or minus the square root of 22.